Hello friends, welcome to our YouTube channel. In this video, we're gonna see how can we create a custom retaining wall subassembly like this. Okay, in the default Civil 3D template, you have only these kind of retaining walls, which we don't want right now. So we want to build a custom one. So for this, we can use subassembly composer, which can be accessed first by searching for sub-assembly composer. Okay, this is here, so let's go ahead and click. So in this sub-assembly composer, you can create all different kinds of sub-assemblies as you want without actually coding it. You can just use simple geometry, even advanced geometry, auxiliary geometry. There is a flow chart for it and other things and other advanced things that you can use. And this when it opens, there is a toolbox, flowchart region, preview region, and parameter region, and then there is property region. You can even drag and uh, make them smaller or larger as you like. Okay, so first thing we have to do is understand this particular thing. So this one, so in a retaining wall, there can be multiple parameters. So first I will open my own subassembly composer that I already created and show you how it has been done and how it can be done. Then first let's understand the variable definitions and everything. Okay, so you see it is very simple one, simple subassembly. Okay, so here I have already done the flowchart thing and already set all the properties, and you can see the preview and all the parameters has been defined and target parameters, input parameter, output parameter. There are two kinds of parameter. We have right now defined only input parameters and target parameters has been defined. So we will first, I will go through these each and every aspect one by one and we'll learn how to create it. Okay, so let's go ahead and start a new one, or what we can do is this has been already defined. I will just show you how we can name, and change the type and everything, and how we can assign this to any particular one, and how we can create points and the links and the steps. These are the three things that are very important to any subassembly. Point, link. Point is a particular point that you can see here. These are the point. Okay, and the one that connects 2 points is link. Okay, and when all the links that connects all the points, then finally it makes a shape. So these are the three elements that needs to be understood. Sub assemblies are made of these three components. And let's move ahead. So first thing you have to define is you have to do a rough on paper or anything and check what parameters that you need to define. Okay, so first thing here for the retaining wall, maybe I will have a variable top thickness, top width, variable top width, and then it is going to be connected somewhere from somewhere. This is going to be the origin point of this subassembly, means this is where it is going to be connected to any other subassembly. Okay, and that's why we have to define this height also. This can be variable as per the conditions that we need. Okay, so this can be variable. So we have one top width, two edge height, or whatever you can, I have called it as edge height. Okay, edge height, I have defined it as edge height. Yeah, I have defined that as height here. So and another thing is then another parameter is how much it will be below the surface that is original ground level, how much it will be below that particular ground level, that we have to see. Okay, another thing is the in this one, this kind of retaining wall, normally this particular part, toe and heel, uh, are almost same, but you can keep it as variable. So sometimes you have backfill over this part, then this there can be this part can be larger while another part will be shorter, can be shorter. So you can define these two as toe and heel widths. Another thing is the depth, this depth of the retaining wall. Okay, so these are the parameters that's need to be defined. I have already defined the top width. Okay, top width. Then inner wall slope. In this one we don't need this, we can just delete it. Hit delete, select the parameter and just hit delete. That will delete that particular parameter. Okay, so top width has been defined. Then edge height, this height has been defined. Then heel width, this defined. To where is the toe depth? Okay, toe width. So you can change the toe and width has been defined. This is the toe depth. I have kept it as toe depth or heel depth, is same thing. Or you can define two parameters to control these parts also. Okay, so sometimes it may be variable. I have defined it as same. So how to define? First we learn to define the parameters. So here at the bottom you see the create parameter option. You just hit on it when it's highlighted, and you see now new parameter has been created. So this is parameter 8. So you double click on the name and you can change this to anything. Okay, but you cannot have like blank in it. Okay, so if you put blank spaces, this will give you an error message. So you have to keep it with numbers and letters. Okay, so you can put it like as a1. Okay, something like that. So you can put it. So name, this is the way you can put it. Then there is another thing, type. You have to select the type. So you can select all different kinds of, it is double, integer, string, grade, slope, whatever. Or it's yes or no, conditional. When you have to do this switch, switch to certain, if it satisfies certain condition, then do this yes or no, then you have to put yes, no. And this is super elevation, as you must be familiar with the road, so we can use this super. And axis of rotation also, it is can be defined, slope direction and the potential pivot region through which uh, um, uh, at which it will rotate. Okay, as an axis. And now this is direction. Okay, so it can be either input or output. So for this case we are only defining input. Okay, there can be output parameter as well. So default value, this default values tells you how the parameter will appear when you import inside the Civil 3D, or as it can be seen in the preview in your roadway mode. Here you see, or the layout mode. Okay, so this one, the roadway mode. So here, like if we change top width, for say it is right now 0.2, if you change it to 0.5, you see how it will change. You notice this has changed. Go again and send another depth below OGL is zero point 0.5 right now. Let's say we make it 1 meter. Okay, so it changed. Okay, so we control. So let's put it back to the original one. Okay, and you see it came back to the original. Here is another option, just fit to screen. You just click on that and it fits to screen. Okay, so this is how you can choose the default value. And this one is the display name. Display name that you will later, when you select this parameter, you will have here in the properties panel, you will have here. This is the part that you have. If you don't put this, it will not be displayed. So you have to put it so that you can recognize what should you enter in this. Okay, you should enter in this what you should enter for this. And further you can add short description if this is very confusing. Sometimes there are a lot of parameters, so it can be confusing, really confusing, so you have can add a description as well. Okay, so now you understand the parameters, how you can define it. So first thing, write all those parameter, type, direction, value, default value you want to see. You just make a sketch on paper and just put it all the things, and then same things you have to put there as a parameter, and the definitions and the display names. Okay, let's delete this part, we don't need this, so I will just hit delete and delete. Now let's go to another setting. Here at the bottom, it's right now it's input output parameters selected. First tab is package setting. Package settings. Here you have the name. You can put the retaining wall name and description of it if you want to. So you can just snip it and save the image and then again upload it so that when you see the retaining wall like this, these images are those, this is how it will appear. Okay, and also you see the name that we put here will appear over there. Okay, let's go to another target parameters. Now target parameters, for this case we have only one target parameter and that is sufficient, the surface, the original ground level. Another thing is in this one, another what we have is, and this target parameter can be of the three types. It can either be surface or offset or an elevation. For this particular case we are only targeting the surface. So let's open a new one. So at the beginning you have a start button here and then you have origin here. We click to screen, we set it, and we don't have any definitions, any package settings, nothing. Target parameter, super elevation, can nothing. Okay, so in this particular, let's go ahead and you just have to click on whatever you want and then drag it simply. So here, automatically a line will be attached from the point to this one. Okay, whatever parameter point or link, whatever you are dragging. Then as you select them, properties will be visible. Okay, and from this you can see there are a number of properties, the points, point geometry type, point geometry properties, links, and everything. Okay, so here right now you see it is, if you zoom in you will see it. Here you have point P1 displayed. Okay, P1 displayed. Now what I want is, in the previous one we saw this is a bit higher, okay, higher than the point where it connects. Okay, if we see, if we select this is the point where it connects and it's higher. So let's begin with the point. So just say point P goes up by, you can change your side anytime, the side is already there, and by default side also you can define, or left or right, so you can change it. Here you can see it as well. This same assembly, subassembly has been used as the right side and left side, alignment as well. So there is no issue with that. So let's go ahead and then now this one, I want it to go up by certain. So for that, what we have to do is how much is the edge height. Okay, so we define a parameter called EDGE edge. But let's go ahead and first demonstrate the point first. Okay, so let me demonstrate you first P1, and this one has a, what kind of geometry do you want, angle and distance. It's self-explanatory. Delta x and delta y means from this origin 0 0 how much you want to do this x direction and y direction. Okay, and obviously negative y is down and negative x is leftwards and rightwards is positive y. And this is self-explanatory. You just have to play around and see. For this particular, I would just want del x and del y. Okay, so del y I want to go up, okay, and del x to be 0. So maybe I want to go like by 0.1, okay, 0.1. You see in x direction it's 0 and y direction upwards positive, it's going at 1. The P1 point is there. Okay, so let's go ahead and from here we go, you can go either direction. Okay, so I will go positive x direction for the top width. Okay, so let's drag another point. And now notice you will have P2. Earlier you say only P1. Okay, so only one point was there. So without, if there is only one point, there cannot be a link, okay, or line. So each line needs 2 points. So now here, when we drag it, automatically it's added and it's in sequence. You see. So now a link will be added. You can turn it on or off from here also, the link. Okay, so let's first see the link. So from P1 I want it here, you can see from origin or P1. Okay, so right now our reference point is P1. From P1 I want to go it in right direction by how much? Let's say zero point 0.5. Okay, zero point 0.5. We just, oh, it's not y direction, x direction. Okay, x direction 0.5. Okay, this one should be 0. Okay, so you see now, fit it, you see it, it's there. Okay, very good. Okay, so it's there. Another way to do it is, earlier I told you as height, we have to define as height and this parameter. So let's go ahead to P1, and what it is right now, 1, we can actually replace by a parameter. So we first the naming is the better idea. So I say as height, and then it is type of double input parameter, and default I would like to see at uh, 0.5, let it be 0.5, or 0.25 to 50 is better. Okay, 0.25, and display name before, so as height. Okay, keep it simple, and here actually you can replace by the name, not the display name. Okay, here you can just, to make keep it simple, I just put the same name. You can keep it different as well, put it different, doesn't matter. As, and don't put the spaces, the way you wrote it exactly you write it here, and now you don't see any error. Earlier you saw error, if I add something, you see there is an error. Okay, error, and there's a message, so just remove it. And now what I can do is, I can now change the value from here, you know, maybe zero point 0.5. Okay, and you see how it changes. Okay, so this maybe 155, whatever you can change, and you see the value changing. Okay, maybe we put 7, you see it went away. Okay, so you see the value changing. Similarly, what you can do for this line, the length of this line, you can put it a parameter. So that parameter is top width. Okay, top width, and it's type of double, and for display, for like preview, default value I want it 0.5. Okay, and this one is top width, top width. Okay, now in this here input I can put it like top width, top width. Okay, very well. And now if we change here, it will change. Okay, so we change it to 1. You see how it changed, it become larger. Okay, so this is how you can define parameter and assign simply. Okay, now this is done. What we can do, the next thing we have to learn is, in this particular, now you have already learned to create a line. So another thing we have to define is target parameter. Target parameter, let's create a surface that we just create, and there is target parameter just like that. Okay, so we select the type, it's surface for now, and we have to name it. So I just name it at OGL, or whatever you want. Okay, original ground level. Okay, so it should target to original ground level, and below that it should go. So for preview value I will add like maybe 0.5, just like that, or maybe 1 meter, 1.5 meter, I put it like that. Okay, so, oh, okay, you see, when you put positive value it will go above, we need below. So OGL is below the retaining wall top, right? So origin below, so 1.5 negative, it should be negative value. Okay, now you see it. It's below here. Okay, now we want a line from P2 that targets to this location, and then we can determine the point, and then how much we have to go from here down. We have to go from this particular OGL. Okay, so for that we again bring a point, and this point is going to target this line. So there is an option in the type here. You will see an option shows x2 surface. Okay, x2 surface. So we say this one targets the surface, but x it's not moving away. You can move it away also, like how many x direction, and then it targets the surface. Okay, so it can be even inclined, we can define it, but for this case we just go it and then we say we are targeting OGL. Okay, so you see we just select the target and it just targeted this. Okay, and offset we haven't defined any offset target, so otherwise we have an option for that as well. Okay, so you see it just targeted. Now further, very clean for now. Another thing that you have to do is, and also you can like move it like maybe how much you after like 1 meter or something meter, you know, but this is fixed. Okay, from this reference x, this reference, it will be fixed how much it will move and target it. Like if I want it point 0.2, okay, so it will move point 0.2 from here, this reference revised text and target it. Okay, but for this case I want it just to be straight. So okay, this starts all set. Okay, so what I will now want to demonstrate you is now interpolate things. I have to just demonstrate to you interpolate. So let me quickly finish this and then I will demonstrate the interpolate to you. Then when we have already, this is the variable length, okay, and this is you can, this one is also variable, but this here needs to always connect to the point here. This one always needs to connect to this particular, which is equal, these are equal, okay, and connect like this. So we have to interpolate it. Okay, so I will just fast forward and reach that button, reach there. I will just reach there and then we'll show. So as you see now, I'm already done with all these lines. Now I want to connect these two. So how do I know the length and how can I carry this? So it's very simple. It's just drag in again, and this time we will not drag the point, we will create a link. Okay, so link here. Okay, and simply this link has to connect P1 and P9. Simple. So you have this option, starting point P1 and P9. That's all. Now it's all done. So we have already defined it. So this one, let me change it back to 0.25 maybe, so it looks good. This one is 1 meter. It does not look good. Now this looks fine. Okay. So now the last thing what we have before importing this and testing in with our Civil 3D, we have to define a state. So we drag it again and we define the state. So for that you have to add each link. You click like this here, or you just select it. There is a button, you select and then move inside, and see it's highlighted. That means it's closed. So just click on it and you see S1, you say the same and no error, that means it's accepted. Now package setting and go to, this is for uh, retaining wall. There should not be any SSS wall tutorial. Okay, so I save it, and this one as a version 1. Okay, there's no other version on our revision. Okay, so you can set it like this and we can save it a certain location that you can import this from. Okay, and keep a name. So we can just put the same name, retaining wall tutorial. Okay, okay, so save. So we saved it. Now we are ready to import it into Civil 3D. Okay, let's go ahead here. Let me delete those, or we can simply, it's already, I have already made it, so and it's already there. So now what I gonna do is, let's let's delete this one, okay, and this one as well, these two subassembly, and let me import this too. So go to the insert, and here import to join or import to tool palette. You can import to tool palette, and then it will ask for an option. So for now we just want to take it, so we have to import to the drawing. Let's import to drawing, and again go to the and say open, and now this, I have the option to add it, so I just add it here. Okay, you see the preview is here. Since I had already set up these everything, all the other details has to be set, so it's that's why it's coming like this. Otherwise in your default setting it will be completely black or solid fill. Okay, I will show in the future video how you can customize it. Okay, now, okay, let's this particular is built with this particular assembly. So now let me select this corridor, and we change the subassembly. Okay, so this subassembly I want to change it. We change it to this particular. Okay, and say okay, apply the corridor, rebuild the corridor. And okay, so there is a problem. Why? Because we did not define the target. Okay, so target is not defined. Okay, so target is not defined, so we have to go selected, then go to this and set our target, and we have to surface, what do we say right now? The surface is surface 3, so rebuild. And despite this, I think it's already built or not. Let's see in the object viewer. Okay, let's see, this has been built. Okay, the grading of the ground can be done, but this one has been built. See, so our assembly is working. Okay, similarly you can add, now what you can do, the visibility of these particular elements, the code sets hasn't been defined, that's why you cannot see the lines for these. If you define it here, go to subassembly composer, and from here point you can define the point codes. If we define it, it is going to be the long video. I will show you in later video how we can define it, how we can customize it. Okay, so if you define it, then it will appear in the corridor. Okay, here it can appear. So right now of two are selected, so we save this and say we increase the size of edge height, or what we want to increase or increase toe depth. So let's see, we put it 0.25. You can see the changes here. Okay, toe width. Okay, toe width, heel width, and the footing depth. Let's see, since 2.3. Let's see. Okay, so changes you can see, and the changes will be reflected in the your corridor also once you rebuild corridor. Okay, okay, why it's like this? Because maybe the targeting is not enough. Okay, so this is how you can build a subassembly, custom subassembly, using subassembly composer. Okay, thanks for watching. In the next video we'll see further more customizations regarding the subassemblies. Have a great day. Like, share, and subscribe to our channel.